Okay, we are going to use these steps to solve any equation that has a radical in it. If it's a square root or a third root or a fourth root, you can follow these same steps. Step 1, isolate the radical on one side of the equation. So what that means is you want only the radical, the root, to be on the left side of the equation, and anything else we want to be on the right side of the equation. So in this problem, we have this 2 that's hanging out in front of our radical, and we want to get rid of it. So we're going to divide both sides of the equation by 2. On the left, we'll have only the radical left. Now the x minus 3 is all under the radical. So this is isolating our radical on the left side, and 4 divided by 2 is 2 on the right side of the equation. Now we're ready for step 2, which says raise each side of the equation to the same power. So if we have a third root and we want to get rid of it, we're going to raise both sides to the third power. You have to do it to both sides of the equation to keep it balanced. So we raise that to the third power, and we raise this to the third power. Now the third root and the third power cancel each other out, so we're left with only x minus 3 on the left, and on the right, it's 2 to the third power, which is 8. And now we're ready for the last step here, which just says solve the equation using techniques we've learned in previous chapters. Obviously, this equation is pretty simple. To solve it, we just add 3 to both sides, and x equals 11. Now on your homework sheet, it says check your solutions. I want us to use this 11 as x, plug it back in, and see if it works. I'll switch colors so you can see that I'm using a blue marker to check my answer. So I'm going to have a 2 outside, a cube root of 11 minus 3, and I'm trying to see if this equals 4. So PEMDAS, I'm going to do what's inside here first. 11 minus 3 is 8. So 2 times the third root of 8. Then we're going to do our third root of 8, which we know is 2. And sure enough, 2 times 2 is 4. Okay, so we've checked our answer. I want to see that written out on your homework. Go on to the next slide. This is very similar, only instead of a root, we have a rational exponent. But you should know that those are the same, right? I could write that as a root. That 3/4 power would just be a 4th root. Rather than doing that, I'm going to use a reciprocal of that when I solve this equation. So you'll see how this works. The first thing I want to do is, again, isolate our radical. I want to leave this x plus 2 to the 3/4 power, leave that on the left, and move everything else to the right. So this minus 1, I want to move to the right side of the equation. So on the left, I'll have x plus 2 to the 3/4 power, and on the right, I'll have 8. Now, like I said, rather than writing this as a radical and having to create more work for ourselves, what you're able to do here is use the reciprocal of 3/4, which is 4/3. We're going to raise both sides to the 4/3 power. On the left, the 3/4 and the 4/3 will cancel each other out. It will basically become to the 1 power. So we only have x plus 2 left over here. On the right, we have to remember what 8 to the 4/3 power means. Now, it would help us to write this one as a radical. So you know the denominator is the root, so we're looking at a third root, and the 4 is an exponent. The third root of 8 is 2, and 2 to the 4th power means 2 times 2 times 2 times 2, which is 16. And then we have a nice simple equation to solve. We subtract 2 from both sides, and x equals 14. Again, we can check our answers. I already used red and blue, so I'll switch to green here. I'm going to check my answer by plugging 14 in for x. Okay? So I will have 14 plus 2 to the 3/4 power minus 1. I'm trying to test if that equals 7. 14 plus 2 is 16. We did what's in the parentheses first, just like PEMDAS says we should. 16 to the 3/4 power means a 4th root. Exponent is a 3. 4th root of 16. Well, what number times itself 4 times base 16? That's going to be a 2. So we have a 2 inside, a 3rd power. 2 to the 3rd power is 8. And 8 minus 1 is 7. Okay, so this one worked. Now you might be wondering, why do I have to go through all this process of checking if it's always going to work? And the reason is it's not always going to work. And on the next slide, we'll see an example of where one of your answers might not work. Okay, so what happens if I get 2 solutions? Let's see how come we end up getting 2 solutions here. Okay. First step, I want to isolate my radical. Well, guess what? It's already isolated. The right side of this equation only has the radical on it. The left side has everything else. We're ready to go. We need to get rid of our radical. Well, it's what kind of root that is, right? That's a square root. So we're going to get rid of a square root by using the second power. We need to raise both sides of the equation to the second power. On the right side this time, right, our radical and our exponent are going to cancel each other out. Square root, second power, cancel each other out. We're left with 7x plus 15. And on the left side, it's x plus 1, the whole quantity, squared. Please don't forget that this means write it twice and use FOIL. All right, so we're going to FOIL on the left. X squared plus 1x would be plus 2x. And 1 times 1 is 1. This is a quadratic equation. In a quadratic equation, we want to get it to say equals 0. So let's bring everything over to the left. It'll be x squared minus 5x minus 14 equals 0. And then we have two basic choices here. When you're looking at a quadratic, check to see if you can factor it first. If you can't factor it, use the quadratic formula. These numbers are nice. These are factorable, right? So I'm able to factor this equation into x minus 7 and x plus 2, which means my two solutions for x are positive 7 and negative 2. Now we have to check both of these answers. I know it seems like a lot of work, but it's absolutely necessary because both answers might not work. And there's no reason or rhyme to this. It's not like the positive one always works and the negative one doesn't, okay? Sometimes one of them works, sometimes both of them work. And we're not going to be able to predict which one it is without plugging them in. So let's plug them in and check. Let's check our x equals 7 first, okay? When you plug in a 7, 7 plus 1 on this side of the equation, and the square root of 7 times 7 plus 15 on this side of the equation. You can take out a calculator and do this math, okay? So on the right side, 7 times 7 is 49. 49 plus 15 is going to be 64. And then we're taking the square root of 64. So this ends up simplifying to 8 equals the square root of 64. Now, is that true? Well, yes. One of the square roots of 64 is 8. So I'm going to put a check mark next to this. This answer works. X equals 7 is a good answer. Now let's try the negative 2 and see if the negative 2 works, okay? We'll be putting negative 2 in for x. So this side of the equation will say negative 2 plus 1. This side of the equation will say the square root of 7 times negative 2 plus 15. 7 times negative 2 is negative 14, and negative 14 plus 15 is 1. So on the left side of this equation, we have negative 2 plus 1, which would be a negative 1. On the right side of this equation, we have the square root of 1. The square root of 1 is 1. Now, it doesn't ask us for plus minus. That means it only wants the positive one. So on the right side, we ended up with a positive 1, but on the left, we got a negative 1. So in this case, our answer, x equals negative 2, doesn't work. Again, that might not always be the case, so you have to check them both to show me which one works.